A very good morning to all the students. I hope every one of you is fine and in your best health. So today we're gonna do our revision of chapter number 1, 2 and 3. So we will be doing some questions and discussing those questions one by one so that you may understand how to write the answers of those questions in exams. Okay, so let's start with the first question. For example, if you move to chapter number 1, so a very common question comes about oxidation and reduction is that you will be given a reaction such as, example, let's take a reaction CuO plus H2 gives Cu plus H2O. Now this is a reaction which you have learned when you have learned oxidation and reaction. So this is the most common reactions which come in the exams. Whatever things are given in your NCERT book, just focus onto that. Maximum things whenever comes in the board exams are only from the NCERT books. Even the reactions which are given in your NCERT books, they come in the exam. So you don't have to study anything from the outside. Just focus on your NCERT book and learn each and every reaction which is given in your NCERT book. Do not leave any activity as well. So you have to learn each and every word which is given in your NCERT book, and that is it. Okay, so like if this reaction is given and then you have to consider that which type of chemical reaction is it and you have to answer it. So maybe you will be asked some set of questions on this reaction, that name the substance getting oxidized. Okay, then next question would be name the substance getting reduced. So third would maybe name the oxidizing agent. So in your class 10th, you won't be asked a direct question that what is oxidation reaction, what is reduction reaction. No, not like that. You should know each and every detail and then you will be asked question for those. So you should be knowing what are oxidizing agent. You should be recalling all your reactions for these. After that, next would be name the reducing agent. Okay, then also tell the type of reaction. So for this, now this reaction is an oxidation reaction. Here it's copper oxide is reacting with hydrogen. We are getting copper and water. Okay, so when we heat copper in the oxygen, we get copper oxide. The copper turns into black color. But if we pass hydrogen gas to that copper oxide, we get the brown color copper back along with the water. So obviously this is an oxidation reaction. Here we see that from this copper oxide, this oxygen is being removed and it is adding up to the H2 and it is forming into water. So it is very obvious that the substance which is oxidized is hydrogen. Okay, so hydrogen is getting oxidized because hydrogen is having oxygen. So addition of oxygen is called as oxidation. So here the oxygen is added in this hydrogen. So that means hydrogen is oxidized. Okay, the substance which is reduced, that means the removal of oxygen or the addition of hydrogen is called as reduction. So this copper oxide is being reduced to copper. Okay, so the first answer for the first one is the substance getting oxidized is hydrogen. Okay, second is the substance which is reduced is copper oxide because the oxygen is being removed from this. And here we can see oxygen, but here is no oxygen. That means it is being removed. So the removal of oxygen is called as oxidation. So CuO, copper oxide, is being reduced. Now third question is name the oxidizing agent. So oxidizing agent is that which helps in the oxidation. So here, since the oxygen is being removed from Cu, so this acts as an oxidizing agent. So the oxidizing agent is, you can also watch the previous lecture. I will provide you the link of those lectures along with the description in the description of this lecture. So please look into that and you will get to know where I have taught you about this oxidation and reduction reaction. That's very important. Okay, now the oxidizing agent is CuO. Okay, and reducing agent which is helping in reduction is obviously the substance which get oxidized is also called as reducing agent because it is oxidizing itself. So it is a reducing agent because it is helping the reaction, this agent, to reduce itself. So that is a reducing agent. So H2 is the reducing agent. Now what is the type of this reaction? So this reaction is oxidation reaction, and along with that we can see that reduction is also going in this reaction. So it is also a reduction reaction. So we can call it as an oxidation and reduction reaction and reduction reaction, and we can call it as a redox reaction. So it's a redox reaction. Okay, so let's move to the next question now. For example, you will be given to translate some word equations in the form of a chemical equation, and then you have to balance them also. The most commonly asked question is all the time is that is potassium iodide. It is asked almost all the time. So these reaction of precipitates, when the precipitate is forming, that means it's a PPT. So barium sulfates are white color precipitates. So you can only write that is a precipitation reaction. If there are some formation of lead iodide, so lead iodide, you have to remember, it's a yellow color substance which is insoluble in water, that is called as precipitate. So in any reaction, if lead iodide is forming, that is a precipitate reaction. So let's start with this potassium iodide. Potassium iodide is added to lead nitrate solution. Okay, so in this reaction there could be certain questions. So this can come from 3 marks, that you have to write the reaction which will be balanced one, and then you have to find out which type of reaction is this, and then observation, what are your observation on this reaction. So now if potassium iodide is added to lead nitrate solution, so number 1 would be, what is your observation in this? Okay, observation means what do you see when this reaction occurs. Then type of reaction, you have to tell type of reaction, and then the next would be balance, write a balanced chemical equation. Okay, so this can come for 3 marks because you have been asked 3 different questions on this reaction. So firstly, we know that whenever potassium iodide is added to lead nitrate solution, we get a yellow colored precipitates of lead iodide. That means the first answer would be, we will get yellow colored PPT, I'm writing in short, it's precipitates of lead iodide. So lead iodide is what? We will write the formula also here, PbI2. Okay, so these are the yellow colored precipitate. So observation is that whenever we mix potassium iodide to lead nitrate solution, we get yellow colored PPT of lead iodide. Second is, what is the type of reaction? So it can be because we are getting precipitates, so obviously it's a precipitation reaction. It is a precipitation reaction. Or we can also write it's a double displacement reaction, because we have read about these double displacement reaction. Okay, so third, we have to write a balanced chemical reaction. You can please watch the previous lectures which are also there in the portal. It's very easy for you to find them so that you can understand these topics again, because we have done it, I think, 4 months back in the month of April and May. So it's very sure that you have been forgotten about those things. So you can watch the previous lectures whenever you want. So the reaction is potassium iodide is Ki. Okay, it reacts with lead nitrate. So lead is Pb, NO3 whole twice. It gives lead iodide plus potassium nitrate. So now you have to balance the equation as well. So it's K here 1, potassium 1, okay, but here is this iodine is 2, so we will write here 2. Okay, now what I have done, sorry, okay, so it's K potassium 2 Ki, then lead nitrate, so it's NO3 here and it's whole twice, so we have to write 2 here because here is also potassium 2, so we'll have to just watch again. So okay, that is balance, I think. Lead 1 NO3 then whole twice, and then here is 2, so it's a balance equation. So this is done. Okay, so now next let's move to the next question. That is a very important question, not very important, a type of important question, because these type of questions, one of these type of questions come in the exams. Most of the time it comes. Okay, so the question is, a metal carbonate X on reacting with an acid gives a gas which when passed through a solution Y gives the carbonate back. So you have to get your mind into the first chapter where we have done some reactions like combination reactions, decomposition reactions. There I've taught you some reactions, and I've just remembered that I've taught you a set of 3 reactions where I've told you a single chemical when mixed with water produces another compound like hydroxide, and then when it's hydroxide is passed through carbon dioxide, it produces another compound, carbonate, and when the carbonate is heated we get the first compound back. So we'll go through that as well, and that will help in this question. So carbonate back, then a gas G during electrolysis of brine. What is brine? Brine is a water which is salt mixed in water in a very large quantity. We call it a brine solution. Brine is passed on dry. It gives a compound Z or Z, which is used for disinfecting drinking water. So identify X, Y, G and Z. Okay, so this is a question. I repeat, a metal X on reacting with an acid gives a gas which when passed through a solution Y gives the carbonate back. A gas G during electrolysis of brine is passed on dry Y. It gives a compound Z used for disinfecting drinking water. So if you remember, the compound which is used for disinfecting water is of always bleaching powder, which is CaOCl2. So whenever we do the electrolysis of a brine solution, like we will pass electricity in NaCl, we always get NaOH, which is called as chlor-alkali process, and along with that we get hydrogen gas and chlorine gas. So when we pass chlorine gas to calcium hydroxide, we get bleaching powder. That is the formation of bleaching powder, because in chapter number second in the acids and bases, where we have learned the production of some salts. So in that we have learned that whenever chlorine gas is passed through calcium hydroxide solution, we get bleaching powder. So that means half of the question is solved. Now we'll start from the top. A metal X. We have to find a metal X. Okay, a metal carbonate. The question has a metal carbonate. A metal carbonate X. So the carbonates we have studied in our chapter are most prominently we have studied about calcium carbonate. So whenever you think about a metal carbonate, just remember it can be calcium carbonate. So if it is calcium carbonate, so when it reacts with the acids, so when calcium carbonate reacts with the acids, we get calcium chloride, and along with that we get carbon dioxide and water. Okay, so a metal carbonate X on reacting with acids give a gas which when passed through the salt solution Y gives the carbonate back. So when we pass this carbon dioxide gas in the calcium hydroxide, we get the calcium carbonate back. So that means we have found out all the things in the question. Okay, so we will write the answer to this. Before I start writing the answer, I would like you to go through once again some things like we have done about the combination reaction. Okay, so there was a reaction when, like, this is the quicklime, CaO is also called as a quicklime. I have told you all these things in detail. CaO. Okay, calcium oxide, which when mixed with water, it's a exothermic reaction and a combination reaction. Then calcium hydroxide is formed, which is called as slaked lime, and this is quicklime. Okay, so this is calcium hydroxide, and a lot of heat is produced in this reaction. Now when this calcium hydroxide is passed through CO2, this is used in whitewashing. This compound is used in whitewashing, calcium oxide. When it is mixed with the water, it produced calcium hydroxide. So when this calcium hydroxide solution is applied on the walls, it reacts with CO2 present in the atmosphere, and it produces a hard substance, which is bright white substance, which is calcium carbonate. So it's a carbonate, it's a metal carbonate, it's a calcium carbonate, and water is released. So when this carbonate is again heated, it decomposes into CaO again, and this gas is liberated. So this is very helpful for this question. You should always remember all these. So when this is mixed with the water, we get calcium hydroxide, and when calcium hydroxide is treated with in the presence of CO2, we get calcium carbonate, and again if we'll heat calcium carbonate, we'll get CaO back. So here, okay, so the gas evolved at anode during electrolysis of brine is chlorine gas. We know that is a chlor-alkali process, and the gas we get is chlorine gas. Okay, so that is Cl2, chlorine gas. Whenever we write a gas, we have to write this 2, because we know that chlorine, oxygen, hydrogen, nitrogen, all these are diatomic gas, and they cannot exist in a single atom. So whenever we write this 2 here, we will understand it's a gas. So always whenever you want to represent a gas, you don't write a single atom. Like you never write hydrogen whenever you are writing about gas. So hydrogen is always H2, and oxygen gas is always O2. Okay, so next is when this chlorine gas is passed through this. Okay, so I'll write the reaction as well. So when the chlorine gas CaOH whole twice, calcium hydroxide is passed through with calcium hydroxide, we get bleaching powder. So CaCl2 is bleaching powder. Okay, so now all these are X and Y, since Y and Z are calcium salts, so therefore X is also a X is also a calcium, can be a calcium carbonate. Okay, so we'll write the other reactions as well here. CaCO2 when react with HCl, the first was a metal here, because this is a calcium carbonate. CaCO3 is calcium carbonate. It reacts with acid, it gives calcium chloride and H2O. Okay, so it produces, so when a metal carbonate reaction with an acid, a gas is produced. So along with that, a CO2 gas is produced. Okay, that is a CO2 gas. Okay, so the next is when calcium hydroxide is passed through this gas, then we get again the carbonate back. We have got all these reactions, so it's very clear to us that what are these elements. So here we have to find out X, Y, G and Z, all these four compounds. So X is obviously X. What was X? So X was a metal carbonate, they asked. So X is calcium carbonate in the reaction. And then Y, so the question was like that, a gas G during electrolysis of brine is passed through a dry Y. So that means first of all G is chlorine gas, and when it is passed on a dry Y means it is a compound. Whenever we pass this chlorine gas on Y, we get compound Z. So whenever we pass chlorine gas on calcium hydroxide, we get a compound Z, which is used as a disinfectant. So we get the compound, so our Z will be bleaching powder, which is CaOCl2. Okay, so this is bleaching powder. So I have done a mistake here. It is not CaCl2, it's CaOCl2. This is CaOCl2. Okay, bleaching powder. So we have got all the four compounds. So X is calcium carbonate, Y is calcium hydroxide, G is chlorine gas, and Z is bleaching powder. Okay, CaOCl2. This is also done. So let's move to the next question then. Okay. So next is, I will give you some questions for your revision worksheet also. So why are aluminum oxides are called as amphoteric oxide? If you remember, the amphoteric oxides are those oxides which reacts with acids and which also reacts with bases as well, because all the metal oxides reacts with acids to give salt and water, but here zinc and aluminium show different properties, that they can also react with acids as well as they react with base. So this also we have done in chapter number 3 about aluminium and zinc, because certain metals like sodium and potassium, they are so reactive metals that they can react with the cold water. So whenever sodium or potassium is dipped in water, they will start burning. And calcium and magnesium do not react with cold water, but they react with the hot water. But aluminium does not even react with the hot water, neither with cold water. It only reacts with steam. Okay, so aluminium here is the first reaction I'm writing you to. It's not a question actually. It's just a. It can be asked as a form of questions, that why is aluminum oxide is considered as an amphoteric. So amphoteric oxides are those compounds which reacts with acids and which also react with bases. So aluminium, when react with any acid, so metals reacts with acid, metal oxides actually, metal oxides or metal hydroxides, when they react with acids, they produces salt, metal salts and water. So this Al2O3. Okay, so it when react with HCl or any acid, it produces AlCl3 plus H2O. So we'll balance this reaction. Al2O3 so Cl, it will be 2Al, so chlorine is now 6, so we'll write 6 here. Okay, and it will be 3H2O. So here we can see that when this metal oxide is reacting with acid, we are getting metal salt and water. So when it will react with base Al2O3, when react with base, NaOH is a very hard base, so it will also give a result. It will produce a metal salt again. It is called as sodium aluminate, NaAlO2, sodium aluminate and water. So here we can see that metal oxide is reacting with acid as well as base. So that is why aluminium oxides are amphoteric oxides. We'll balance the reaction. NaOH, Al2O. So here H2O. So it will be Al2. It will be 2 here and 2 here. Okay. So it's sodium aluminate. Okay. So one more question we'll do and then we'll end this here, and I'll give you some more questions for your worksheet, and so you can do and you can ask about those questions if you have any problem. Okay. Now one more most importantly asked questions. What is Thermite reaction? This also you have learned when we were doing our chapter number 3. So what is Thermite reaction? The Thermite reaction is used to join the cracks on the railway tracks, because in the railway tracks there might be some cracks, so that are treated by pouring liquid iron in that. So they cannot liquefy the iron there all the time, so they use this Thermite reaction so that the iron is in the molten form. How it happens is, when this ferric oxide Fe2O3 is called as ferric oxide, it reacts with aluminium. So when ferric oxides reacts with aluminium, a lot of heat is produced. Because of that heat, the iron comes in the molten form. So we get iron here. So this iron is basically in the molten form, and this molten iron is poured in the cracks of the railway tracks, which is used to join the railway tracks, cracked machine parts, because the heat which gives out in this reaction, it melts the iron, and the molten iron is it is poured into the tracks and it welds them together. Along with that we get aluminium oxide Al2O3 plus a lot of heat. So you have to mention heat here. So it's a Thermite reaction, and in this the iron oxide and aluminium are reacted, which produces a lot of heat. Okay, so this. So a sulfate salt of group 2 element. So we will do when this chapter number 5 we will learn about these groups. So I will tell you group 2 elements are called as alkaline earth metals. So there is a sulfate salt of group 2 element of a periodic table, so which is white soft substance. So it can be molded into different shapes. So whenever this will come, you have to remember about plaster of Paris, which we have done. Okay, so what is plaster of Paris? It is calcium sulfate hemihydrate. Do you remember the formula? If not, please go through the previous lectures. Okay, now this sulfate salt, which is group 2 element, which is white soft substance molded in different shapes to get we can make a dough and we can make different things out of that. So when this compound is left open for some time, what happens when we will leave it for some time, it will become a solid mass and cannot be used for molding because it will take a shape. Okay, so identify the sulfate salt and state why does it show such a behavior, give the reaction involved. So now the substance which is used for making different shapes is plaster of Paris. So the answer is plaster of Paris. I'm writing POP here, it's plaster of Paris. And the calcium chemical name is calcium sulfate hemihydrate. Okay, which is called as CaSO4 dot 1/2H2O. So we can also write here 2CaS, or we can write 2CaSO4 dot H2O. That means when we are using two molecules of calcium sulfate, the half molecule of water is distributed. So we can also write like this. Okay, both ways it's right. So now whenever we just leave it in the atmosphere like that, it absorbs the moisture. So when it absorbs the moisture, what happens? CaSO4 dot half H2O, because it's a hemihydrate, half it will react with 1.1.5 molecule of water. Okay, 1.5 molecule of water to make gypsum, CaSO4 dot 2H2O. So it's a gypsum. So it is made from the gypsum. We have done how it is formed. So when we will heat this gypsum, so this 1.5 molecule of water will be removed and we'll get this POP. So it will form into a solid mass called as gypsum. Okay, so this is the last question which I'm telling you. So you can practice more questions so that you may help, because going through the lectures and reading the book is not sufficient. You have to practice questions, then only you will be able to answer. So I'll give you some more questions in the worksheet, so please try to solve them, and if you have any problem in those, you can ask me in the class group. Okay, so till then, take care and study hard. Thank you.